day, learners. Now we are going to have operations with radicals, particularly multiplications of radicals. In this lesson, you are expected to multiply radicals. To multiply radicals with the same index, use the law on radicals. Nth root of A times the nth root of B is equal to the nth root of A times B. Then simplify by removing the perfect nth powers from the radicand. If with coefficients, use quantity x, nth root of A, times quantity y, nth root of B is equal to x times y, nth root of A, B. The indices are not multiplied together. So take note, you are just going to multiply the coefficients and the radicand. For example, we have 3 square root of 2 times the square root of 6. So first, we are going to multiply the coefficients and multiply the radicands. So therefore, we have 3 times the square root of 12. Why? Because 3 times 1 is 3. Square root of 2 times the square root of 6 is the square root of 12. Then, we factor the radicands. Because the square root of 12 could be simplified, and it has a perfect square factor, which is 4. So we are going to have 3 times the square root of 4 times 3. Therefore, we are going to simplify it as 3 times 2 square root of 3, since the square root of 4 is 2. Therefore, we have 6 square root of 3. Next, we have 2 square root of x times 5 square root of 6x times the square root of 2x. So we are going to multiply the coefficients and then multiply the radicands. Therefore, we have 2 times 5 times the square root of x times 6x times 2x. Therefore, we have 10 times the square root of 12x cubed. Since the square root of 12x cubed is not in its simplified form, there is a need for us to simplify our radical. So, we are going to factor out 12x cubed into perfect and non-perfect nth power. So, therefore, we have 10 times the square root of 4x squared times 3x. So, therefore, we have 10 times quantity 2x times the square root of 3x, giving us 20x square root of 3x. Another example, we have the cube root of 4x cubed y squared times the cube root of 4x raised to 5 y squared. So therefore, we have the cube root of 4x cubed y squared 4x raised to 5 y squared, giving us the cube root of 4 times 4 is 16, x cubed times x raised to 5 is x raised to 8, y squared times y squared is y raised to 4. So, simplifying, we are going to break down our radicand into perfect and non-perfect nth power. Therefore, we have the cube root of quantity 2 cubed x raised to 6, y raised to 3 times quantity 2x squared y. Therefore, we have 2x squared y times the cube root of 2x squared y. To multiply binomials with radicals of similar index, we either use the distributive property or apply the special products of polynomial expressions or simply use the FOIL method. For example, we have quantity square root of 2 plus square root of 3 times quantity 4 square root of 2 minus 2 square root of 3. Using the FOIL method, we are going to have the square root of 2 times 4 square root of 2. So therefore, we have our first term 4 times the square root of 2 times 2. We have square root of 3 times 4 square root of 2. So therefore, we have positive 4 square root of 2 times 3. Then square root of 2 times negative 2 square root of 3. So we have negative 2 square root of 2 times 3 and negative 2 square root of 3 times the square root of 3 is negative 2 square root of 3 times 3. So therefore, we have 4 square root of 4 plus 4 square root of 6 minus 2 square root of 6 minus 2 square root of 9. So therefore, we are going to have 8 plus 2 square root of 6 minus 6. Simplify it further as 8 minus 6 plus 2 square root of 6. Therefore, we have 2 plus 2 square root of 6. Next is we have to simplify the square root of 2 minus the square root of 5. If we are going to make use of the FOIL method, we can expand this expression as square root of 2 minus the square root of 5 times the square root of 2 minus the square root of 5. So applying the FOIL method, we have this equation, square root of 2 times the square root of 2 minus the square root of 2 times the square root of 5 minus the square root of 5 times the square root of 2 plus the square root of 5 times the square root of 5. Simplifying it further, we have the square root of 4 minus the square root of 10 minus the square root of 10 plus the square root of 25. So therefore, we have 2 minus 2 square root of 10 plus 5, giving us 7 minus 2 square root of 10. And aside from using the FOIL method, in this particular example, we can simply square the binomial by squaring the first term plus or minus twice the product of the first and second terms plus the square of the second term. So square the first term, so we have square root of 2 square minus 2 times the square root of 2 times the square root of 5 plus square the last term, so we have square root of 5 square. So therefore, simplifying it further, we have 2 minus 2 square root of 10 plus 5. Therefore, we have 2 plus 5 is 7 minus 2 square root of 10. So either of these two solutions, you have the option to make use of the squaring a binomial, or we can expand the given square of a binomial to make use of the FOIL method. To multiply radicals of different indices, it is necessary to change them all to the same index. So how? First step, we need to transform the radicals to equivalent expressions containing fractional exponents. After which, we change the fractional exponents to equivalent fractions having the same denominators. And lastly, transform to radical form and proceed to multiplication of radicals. Example, square root of 6 times the cube root of 5. Since the two radical expressions do not have the same index, we cannot multiply them right away. So we need to change first the expression to fractional exponents. So transform the radicals to fractional exponents. So we have square root of 6, which is equal to 6 raised to 1/2, while the cube root of 5 is changed to 5 raised to 1/3. So we change the fractional exponents to equivalent fractions having the same denominators. So the least common denominator of 1/2 and 1/3 is 6. So therefore, we have 6 raised to 3/6. So 1/2 is transformed to 3/6, while 5 raised to 1/3 is transformed as 5 raised to 2/6. Therefore, we can transform to radical form and proceed to multiplication of radicals. So 6 raised to 3/6 could be changed as the 6th root of 6 cubed, while 5 raised to 2/6 could be changed as 6th root of 5 squared. Since the indices are already equal, we can now proceed to multiplying the radicands. So therefore, we have the 6th root of 216 times 25. 216 is actually 6 raised to 3, while 25 is 5 squared. The product of the given radical expression, square root of 6 times the cube root of 5 is 6 root of 5,400. Next, simplify the square root of 3 times the cube root of 2. So like the usual, since the index are not the same, we need to change them to expressions with fractional exponents. So therefore, we have 3 raised to 1/2 times 2 raised to 1/3. Then we change the fractional exponents to equivalent fractions. Therefore, we have 3 raised to 3/6 times 2 raised to 2/6. Since we have already the same denominator for our exponents, fractional exponents, we can now turn it back to radical expression. So therefore, we have the 6th root of 3 cubed times the 6th root of 2 squared. So therefore, we have the 6th root of 27 times 4, which is equivalent to the 6th root of 108. Remember, multiplying radicals with the same indices, simply multiply the radicands. Radicands times the radicand, while coefficient is multiplied to coefficient. When multiplying radicals with different indices but the same radicands, we convert the radicals to exponential form and apply the laws on exponents. When multiplying radicals with different indices and different radicands, just the same, we convert the radicals to exponential form with exponents that are similar fractions. And lastly, always express the final answer in simplest form. So let us have this activity. In answering the activity, kindly pause this video to give you ample time in simplifying the given radical expressions. So number 1, square root of 8x times square root of 4x times square root of 3x. We are going to have 4x times the square root of 6x. Number 2, 3 square root of 5y times the square root of 6y times the square root of 12y. The answer is 18y square root of 10y. Number 3, square root of x times quantity square root of x plus the square root of 2. So therefore, we have x plus the square root of 2x. Number 4, 5 minus the square root of 2 times 5 plus the square root of 2. We have 23. Number 5, the square root of 2 times the cube root of 2. We have the 6th root of 32. Did you get the answers correctly in this given activity? If yes, well done. But if not, do not worry. You can rewatch this video in order to understand the lesson. So, that's all for today. Thank you and God bless. Happy learning!